Okay, let's log in and perform some configuration here. The first thing we want to do is we want to bring up the fabric, right? So we want to get the Internet Edge router, the Palo Alto firewall, ASA, and campus router or switch configured. So let's start with the Internet Edge router. Just going to create some access policies here. Start off with an AEP, and the only thing that's configured here is ESX and VMM integration. With the VMM integration, we have 2 ESX servers. ACI is pushing out a virtual distributed switch to our ESX servers. So basically, part of this video series, you're going to see me create that application profile, those EPGs, map those EPGs to VMM, so that ACI pushes out the port groups corresponding to the EPGs, and we'll do some testing. So let me just start configuring the Internet Edge router. So I'm going to do an AEP here. So I'm going to call it Internet Router 1 AEP. And we're going to have to configure a physical domain. Call it Net 1 physical domain. We're going to create a VLAN pool. So iNet1 pool can be a static VLAN 667. All right. So we got the AEP, we got the physical domain, we got the VLAN pool. So I'm going to hit finish here. Now we got to configure our interface policy group. And this router is going to have a single home connection. It could be dual home, then we could do a VPC. But in this case, we're just going to use one link here. Internet 1 policy group. We're connecting at 1 gig. CDP is on. And we're going to go to the AEP. The AEP is basically the iNet 1 AEP that we just created. I'm going to hit submit here. And we got to go down to profiles. We have to create our interface profile. So that's going to be iNet 1 interface profile. And we got to pick port. So this is basically, we're connecting to, I think it's leaf 1. Let me check, hang on. Yeah, it's leaf 1. So we're connecting on port 13. Here's my iNet 1 pull group. And I got to apply it to a switch interface profile. And I already have a switch interface profile that is configured for leaf 1 and leaf 2. But because I'm only going to be applying the configuration to leaf 201, I need to create a separate leaf profile. So I'm going to call 201 profile. And I'm going to call this 201. I'm going to select leaf 201. And I'm going to go into leaf 201 and I'm going to apply the interface for iNet 1 that I just created. This will establish connectivity to that actual interface. All right. And we'll verify everything after. So let's go to the Palo Alto firewall now. And the firewall, the Palo Alto firewall is configured in a virtual port channel, in a port channel on the actual firewall itself. So let's create a global policy here. It's a PAN 3020 AAEP. We're going to create a physical domain. That physical domain is going to be PAN 3020. Copy this. Physical domain. We got to create a VLAN pool. So we're going to use VLAN 666 and VLAN 2000. So let's create VLAN 666 and VLAN 2000. All right, so now we got our physical domain, our VLAN pool, our AEP or AAEP. Now we got to create our policy group. So we're going to create a virtual port channel. And this is our PAN 3020. Let's call this pole group, just to keep the naming convention. We're connecting at 1 gig. I believe we have LDP on. Let's make sure CDP is off. Not going to matter really. Port channel is going to be a LACP active. And our AEP is the PAN 3020 AEP that we just configured. I'm going to submit that. And I got to create a profile. So I'm going to just create leaf interface profile. PAN 3020 interface profile. And I'm connecting on the Palo Alto, let's see, port 117. So I'm just going to type port 17, 1/17, and I'm going to apply the PAN 3020 policy group to that. And because the Palo Alto is connected, is dual home to port 17 on both leaf switches, I'm going to apply the interface profile that I just created. I'm going to apply it to both switches. So I'm going to go here, I'm going to select the PAN 3020 interface profile, submit. This should configure an ether channel. So let's hold off on testing. We're going to test it in a little bit. Let's move forward. Let's let that configuration bake in, and let's configure now the ASA cluster. So we're going to create two different AEPs for the ASA cluster. ASA 5500X cluster. Let me just copy this so I could have it. And we're going to create the CCL, the cluster control link first. So we're going to create a physical domain. We're going to do CCL pool, or physical, sorry, this is the actual physical domain. And the VLAN pool, we're going to create a VLAN pool. So that VLAN pool, we're going to actually use, let's just use VLAN 20999. That's going to be the VLAN that we use to establish communication across all of the cluster control port channels among all members in the cluster. So I have my AEP physical domain, my VLAN, next finish here. I'm going to go into policy groups under interface policies, and now I got to configure my virtual port channel for the CCL. So we're going to do a port channel for CCL1. It's going to be 1 gig, CDP on. Port channel is going to be active. AEP is going to be the CCL AEP we just created. Scroll down, hit submit. So that is my CCL link. Now I'm going to create a leaf interface profile. So what I'm going to do here is I'm just going to create a profile for the cluster itself, and that cluster is going to have the CCL and the data interfaces together in the same profile. I'm going to go here and I'm going to make the access port selector different. I'm going to say cluster CCL1 ports, and the CCL is connecting on port 8. So 1.8. So basically the CCL on this particular on the ASA1 is connecting to port 8 on both leaf 1 and leaf 2. So we're going to put the policy group as the CCL1 that we just created. And once the cluster is up in operation, I'm going to go back here and I'm going to add the data interfaces. So before we do the data, we want to make sure that the cluster control link is operational. So I created my profile and I want to go into my leaf profile. So because the firewall is going to have the same connectivity across leaf 201 and 202, we're going to add the interface profile to leaf 201 and 202 as a single switch profile. So I'm going to go in here and add the cluster control, the cluster interface profile. And while I'm doing that, I need to go into tenants, and I want to configure my the EPG that cluster control link is going to connect into. So I'm going to go into tenant common, and let's create a VRF. Let's call it management. Let's create a bridge domain along with that. Bridge domain name management. I'm going to go back into this bridge domain. One thing that you guys got to remember or keep in mind is that flooding needs to be enabled for the cluster control link. Otherwise, you're going to have problems. And there's going to be no unicast routing on that link. So go into my application profile, and I want to configure my ANP for management. And under ANP management, I'm going to create an EPG called ASA 5500X cluster CCL. It's going to be part of the management bridge domain. And I need to map it now. So if I go in here, I'm going to add the physical domain of the actual cluster control link physical domain that we created, and we're going to bind the interface. So we're using a virtual port channel CCL1, and it's coming in on VLAN 2999, and we're going to set up as untagged. So basically, the next ASA cluster CCL2 is going to be untagged. It's going to be also on VLAN 2999 because they're part of the same EPG. They're going to have communication, and the cluster control link is going to be operational. In this particular design, I only have one ASA because the other one is being serviced. So I could only show you the configuration for one. But it's the same thing for the other one. I would configure the other one in the same way and add it here. So let's check the fabric inventory. Let's see the port channel configurations so far. So here's my VPC, here's my CCL, and I have a Palo Alto. So let's just check the ASA first. So the ASA picked up, oh, here you go, picked up PO48 on the ASA, which is already configured. And if I click here, okay, so basically the interfaces were down, but now the faults are clearing. And as you can see here, soaking, clearing, because the port was down. Now this is actually going to clear up, and everything's going to be functional in a couple seconds. So if I click actually here and I scroll down, you're going to see here that we now have, it's in the channeling status channeling, and here's the AEP that we applied. So if I log into the ASA, I'll be able to see that the port channel is up and operational. So these messages are going to clear out in about, I would say, 3-4 minutes, if not sooner. And as far as our Palo Alto, here's the Palo Alto port channel. If I scroll down here, you're going to see that it's channeling because the aggregate interface is already configured on the Palo Alto, but I'll show you how that looks in a couple seconds or a couple minutes. So VPC is pretty much configured. Let's see, what do we need now? Let's configure the data interfaces on the ASA, and we're going to test everything in a little bit. So I'm going to go back to the access policies, and let's configure the data AAEP. We need a physical domain as well. So it's going to be physical domain, and let's create a VLAN pool. Data pool. So what VLANs do we want to use? We want to do on the ASA, we want 2000, 2001, and 2002. So I'm going to create it from 2000 to 2002, static allocation, submit, submit, update, next. So I created my AAEP, physical domain, VLAN pool. I need to now create my policy group. So let's do a VPC. Keep in mind that we're going to be doing a span ether channel. So it's pretty much going to be one port channel across multiple ASAs to the ACI fabric, right? Or the ACI fabric is going to see one port channel but it's going to be spread across multiple ASAs. So I'm going to go in here, and I need to configure the actual data policy group. So that's going to be 1 gig here. It's not going to matter for CDP. Port channel LACP, and then the AEP is going to be the data AEP that I just configured. So I'm going to hit submit here. And all I need to do here in the profiles is I already created this interface profile for my 5500X. So I'm going to go into this profile, and I'm just going to add, okay, my ASA cluster data ports. So from this single ASA that I have, I'm connecting in on port 17. If I was to bring in my secondary ASA to join the cluster, then I would go back in here and I would put in what port it's actually connecting on both leaf switches. But this particular ASA is connecting on port 17. So I'm going to go in here and I'm going to select my cluster data policy group. And when I do that, this cluster interface profile is already added to the switch policy. So I don't need to go back in here and do anything because it's already part of this ASA 5500X cluster interface profile. So that is operational. We're good to go. So the only thing I probably would need to do is just kind of validate from the fabric side, and I could go in here. I could go, for example, to leaf 201, VPC, and I could see that here it is, right? So here's the data policy group, and it's got some faults. Let's see what those faults are, but they're clearing up. So the port was basically deployed, and it wasn't available or ready yet, and the port channel was in configuration state. So in about a couple minutes, this is going to clear out, and this is going to be a fully functional interface. Well, it's functional now, it's just a fault. The fault's going to clear out. All right, so the fabric is configured for the Cisco ASA firewall. We're going to test it all from the actual ASA in a couple minutes. Let me just configure the last thing here, which is this campus and WAN router. Let's call it a router. It's actually a switch, but let's call it a router. So lastly, we're going to go into the AEP here, and we're going to configure our campus 1, and we're going to do AAEP as the name for the AAEP. We're going to create a physical domain. So campus 1. Just copy that, campus 1 physical domain, and the VLAN pool. So we're going to use, let's see here, VLAN 900. So static allocation. All right, so I got my AEP configured. Now, as usual, got to create my policy group. And this is just going to be an access port. So, campus 1, whole policy group. It's going to connect at 1 gig. CDP is on. There's no LDP. We don't got to worry about that. And the AEP, which we just created, was here, campus 1 AEP. Submit. Now, profiles, so that we could actually deploy this. So, it's going to be called interface profile. And the selectors, we're connecting on port 3, 1/3, and here's the campus policy group. So this switch or router is connecting on leaf 202. We can't use this switch profile because this switch profile assumes that that device is going to be kind of dual homed and connected into both. We can't use 201 because the switch is actually connected to 202. The router is connected to 202. So I got to create another leaf profile for 202. And I'm going to use 202 here as the name, and the blocks I'm going to use switch 202. Next here, we create it, and oops, and then I'm going to open up 202, and I'm going to add the campus interface profile here. So basically, all this is doing is it's associating the profile that I configured, which basically states that the campus switch or router is connecting to port 13 on the ACI fabric, and it's connected to leaf 202. and that is just an access port, and we're using certain VLANs to communicate with that device, and that was VLAN 900. All right, so let me prep the ASA firewall real quick. So this firewall is already configured for multiple mode, multi-context mode, and it is configured for clustering. But we're going to add some configuration. Let me no context corporate, and then no interface or channel 2.2000. I had a previous configuration, so we could do it from scratch. So if we see here, we have channel group 2 on the data interfaces and channel group 48 on the cluster control link. And there's some other port channels configured here. So you're going to see here, port channel 48 is the CCL. We have a cluster control cluster configuration. Let me just show cluster info. All right, so it's operational. It's talking on this this cluster interface. So there's nothing else. There's no other member here, so we're not going to be able to ping the other member. All right. So what we're going to do here is we're going to need to just quickly create a context so that we could use it for this communication. We need to create VLAN 2000, 2001, and 2002, and we need to prep the firewall, and we can do some simple testing. So let's configure port channel 2.2000. That's going to be VLAN 2000. We're going to do 2001. It's going to be VLAN 2001, and 2002, and that's going to be VLAN 2002. And then let's create context corp. Context corp. Config URL. Let me just set this up real quick. Oops. We got to allocate interface management 00 so that we can manage it. We got to allocate interface port channel 2.2000, 2001, and 2002. That's about it. Let's just jump into that context now that we created. What is it called? Port. There you go. So you're going to notice here that we have a blank configuration. So we have our management, our port channel 2000 and 2002, nothing else. Let's configure this thing real quick. Interface, I'm going to create a pool. IP local pool, let's call it pool. 32, we got, let's do 191 through 172.30.32.192. And then my interface management 00. Only name if manage. Oops. Only. Secure level 100. IP address 172.30.32.190. And it's going to be the part of that cluster pool. There you go. Shouldn't be shut down. So that's our management. Let me just create a route. Management only. It's going to be for route out. 254 should be the default gateway. Let me just check. All right, cool. We got connectivity. So let me configure port channel 2.2000. If we go back to the diagram, 2000 is going to be our outside DMZ. So that's going to be our outside DMZ. good security level. IP address is going to be 10.99.99.2. 10.99.2. All right. And let's configure our interface port channel 2.2001. 2001 is going to be our inside campus. So security level 100 here, and IP address 100.065. 10.100.065. 192. And let's configure port channel 2.2002. Name if. This one is actually inside data center, inside DC. So we'll do inside DC, security level 99, and the IP address 10.100.0.1. That one I remember well. All right, let me just create some access lists here so that we're not messing around with troubleshooting access lists. Permit all, permit IP any, and let me apply it globally. All right. Let's check here. Got a couple things here. Again, I'm just doing this just so that we can verify all connectivity, and then, you know, later down the line, you guys can start tightening down these security policies. We're also going to need to set up, while I'm in here, let me do the OSPF routing. So I'm going to add these two IP blocks to the OSPF process and do a static route to the Palo Alto. So let me do, what's the show interface, port channel 2.2001, 2002. Okay, so we're going to do router OSPF1. Let's do the router ID. Otherwise, if we don't do a router ID, we're going to have problems with establishing in the JSSC. That's what I've been noticing. So network 10.100.0.0 255.192 area 0, and then the 64 block. And it's also originate a route, default route into the network. All right. Let's see where we're at. So we got the OSPF process running and static route. So route outside DMZ. So that will be to the 10.99.99.1, which is the Palo Alto. Let me save that config. Yeah, it's the one. Okay. So the ASA should be functional at this time. Now let's go in and configure the tenants and establish that connectivity. But we should have good, we should have the proper access policies for the edge router, the Palo Alto firewall, the ASA, and the campus switch. But actually, you know what? Let me go into the Palo Alto real quick and configure the Palo Alto for these policies. So let me open up another page. Palo 172.32.23. There you go. All right, so logged in. So I have here that aggregate Ethernet. That's why my port channel is coming up. So I need to modify this. So we got subinterface 2000 already. Let me just add an IP address here. So 2000 was the 1099.1. 1/24. And we got to create a management profile. I think management profile here, I think allows pinging, so we could ping the actual interface. So So I'll come back here and I'll set the default router, the actual virtual router, so that we can do routing. Let me do another sub interface, AE1. This is going to be 6666, I think. Yep, 6666. IPv4, that's going to be 200.4/24 by 200.4. Yep. Okay, all right. And we're going to have to come back into this guy actually and go in here. Set the management profile. Let me configure the virtual router real quick. So the default, some static routes, add default route. So 0. Next hop will be 200.200.1, which is the Internet Edge router. It's okay for now. And then we're going to do the 10 network. I don't think we really need this, but oops, let's call it inside network. But let me just add it just in case, because we're going to be doing natting. So that's going to be 10.99.99.2, which should be the ASA IP address. Yep. Okay. So we should be all right here. So let me go back into interfaces and add this virtual router. Put the default security zone is going to be untrust. And then on interface 2000, same thing. And the security zone, we have to create a new zone here. Let's call it DMZ trust. And we'll add 2000 here. That's good. Alright, so we got untrust, trust. So far, so good. Now I need to create some objects here. So let's do DMZ01. We're going to create a private IP for it. And that is the 1099. So we're going to have to the host that's going to connect into DMZ1 EPG, we're going to give it an IP address, a private, and then a public so that it could go NAT through the Palo Alto firewall. So let's define them first. So it'll be 20. DMZ01 private will be 20. DMZ02 private will be 10.99.99.21. Let me set the publics now. So DMZ01 public. Oops. It'll be 200.200.20. And this guy is going to be DMZ02 public 200.200.200.21. Alright, so I got the objects. Let me go into policies and create a quick security policy here. And just create a default policy. Source any destination, any application, any action allow. This is just so that I could pass all traffic through the firewall. Again, I'm not worried about testing security right now. I just want to make sure that testing is good. So natting, let me create a NAT policy here. So let's do the DMZ servers here. So DMZ01, original, it's going to be coming in from the DMZ trust zone. It's going to the untrust zone. And it's coming in from DMZ01 private. And translated packet would be dynamic IP and port. And we're going to do, no, not dynamic, I'm sorry. It's going to be static NAT. And we're going to do DMZ public, bidirectional. Okay. Let me do the same thing for DMZ02. So it's going to come in from the DMZ trust. It's going to the untrust. Source address is actually DMZ02 private. Original packet static, and it's going to use the DMZ02 public bidirectional. Okay. Now let's also just get a general connectivity out. Internet access. Well, actually, you know what? We're going to do DMZ trust because it's going to come from the DMZ segment, and destination zone untrust. We're going to do any source address. Translated packet would be the actual PAT address, which is dynamic IP import, and we're going to use the interface address for that. So we'll NAT ourselves to for anything that's not going to be a DMZ server. We're going to be using the AE the 666 interface, which is IP 200.4. All right, so we're in good shape here. I got all the objects, policies, I got security, I got NAT, I got my network, my interfaces, my zones are configured. My virtual router has the static routes. So let's see, I'm going to be able to ping the interface. I got my IP addressing. I think we're good. Let me commit this here and make sure that this configuration is applied correctly. All right, perfect, no issues here. Awesome. So we now configured our Palo Alto. So let's start configuring the actual tenant. All right. So recap here, router is configured, Palo Alto firewall is now configured, ASA cluster is now configured, the campus and WAN router is now configured. Now let's configure the actual tenant. So let's do the tenant internet edge and configure BD public and BD DMZ within the tenant or in the VRF. Actually, we're going to configure the tenant, the VRF, the BD, and then the EPG. So let's do that real quick. So I'm going to go to add tenant. We're going to call it the internet edge. And let me just create this way first. So we're going to have two VRFs. We're going to have VRF public and DMZ. Okay, and then we got to create some bridge domains. So we're going to configure, the first one is bridge domain public, and of course it's going to map to EPG public, VRF public. And this one is not going to have any unicast routing, but it's going to have ARP flooding. It's not going to have anything else. It's not going to be layer 3, it's just going to be layer 2. We're going to connect our router and outside Palo Alto firewall in there. And let's also configure our DMZ bridge domain. It's going to be associated to the DMZ VRF. Similarly, this is just going to be layer 2 connection, so we're going to do ARP flooding here. We're not going to do anything else. Just these, for this DMZ bridge domain. Well, actually, you know what? We're going to need to enable that because this EPG. Let me think about that. Oh, let's test connectivity. I think we're going to be in good shape if we enable this for traditional hardware proxy. Well, that is already hardware proxy. So let me see here. DMZ. All right, so it's for hardware proxy, but let's just enable ARP flooding because I think we're going to need that for the Palo Alto and ASA firewall connectivity. We could test it later if we actually need it or not. I remember having some troubles in the past, so let's keep it on for now. Okay, where are we at? So we got the bridge domains, bridge domain DMZ, bridge domain public. Perfect. Now let's configure our application profiles. So we now need to configure our AMP for public. So yeah, let's just call it public. And in here, we're going to create an EPG called public edge. And this bridge domain is going to be public. And we're going to add the domain in a little bit. So let me just add that here. I'm going to create another EPG. It's going to be called firewall DMZ. This is where the firewall interfaces are going to connect into. This is the meet me zone, and they're going to be under the DMZ. And we're going to do this later as well. And then we want to create DMZ1 in the DMZ as well. And we're going to, I'm going to do this another way. And DMZ2. Harder DMZ BP. Okay. So I created my EPGs. And what I just did here, I just basically created this EPG, and these two EPGs. And they're associated to their corresponding bridge domain. All right, so here's my application profile for public. I want to separate that. All right, that's a typo here. Let me correct this here. I actually just want public edge in its own profile. I want to keep things separate. So I'm going to just delete these here. I apologize about that. Let me configure a separate application profile. And we're going to call it AMP DMZ. I'm ahead of myself here. This is going to be the firewall DMZ, bridge domain DMZ. Set that up later. And then again, let's do this one more time. DMZ1. These are all connected to the same DMZ bridge domain. DMZ2. So again, I have a separate application network profile for my DMZ, because these are technically separate, right? They're separate to the separate VRF, even though we're treating this as an ACI fabric as a layer 2 for these services, but we still have to follow the logical constructs. So let's get the internet edge connectivity squared away here. So under the public A&P, we have that public edge EPG. So what we want to do here is we want to add the physical domain for the internet edge router and the Palo Alto firewall, because the Palo Alto outside interface is going to connect in here. And we want to bind these. So if I go back here, VLAN 667 untagged is what the router is going to connect into, this particular EPG. So let's configure that. So I already forgot, what is it? Leaf 2, I think it was Leaf 201. So I'm going to go to Leaf 201 here, port 13667, and this is going to be untagged. This is for the actual router. And then I'm also going to add the virtual port channel for the ASA data interface. And no, not the data, I'm sorry, the Palo Alto. And the Palo Alto is going to connect on VLAN 666. And, oh, actually, we're going to set up as a trunk, because port channel, and we're passing VLAN 666 as you notice in the Palo Alto config. Alright, so at the static bindings here, and let me see if we have, alright, so we're learning something here. This is from the actual router itself. Alright. Here are my access policies that I configured. All right. So we're going to test connectivity in a little bit. So this is the Palo Alto connecting to the Internet Edge firewall. So this is the EPG. We did some EPG bindings here. All right, so let's configure the DMZ now. So if we're going to go into our DMZ application profile, here's the EPGs that we configured, DMZ1, 2, and the firewall DMZ. So for DMZ1, we're just going to associate our VM where we have a virtual distributed switch being pushed down through the VMM integration. So once I do this, it's going to push down a port group, and I'll show you how we assign them. So that's DMZ1. We're going to assign a VMM here as well. And for the firewall DMZ meet me, where the default gateways are going to actually reside, we have to add the physical host here, physical domain here actually. So we're going to add the Palo Alto physical domain. So what we're doing here is we're configuring this guy now, this EPG, and it has the Palo Alto and the ASA. Now let me get the virtual machines up. Let's go to here. Let's assign the port groups. So you're going to notice that my DMZ1 port group was pushed through that VMM integration that we just did, associating the DMZ EPG with the VMM. And let me set DMZ Web 02 to a separate port group, because I want to make sure, the way I'm kind of doing this is I'm classifying this DMZ1 endpoint group as being a unique group of DMZ servers, and this being a different group of DMZ servers. So I don't want there to be communication between both, so I'm going to establish them. I'm going to configure them in separate EPGs, and they are going to have contracts with the firewall DMZ EPG here for default gateway access. So let me log in. Reconnecting here. Open the console here. So let me ping the default gateway, which is the Palo Alto. So let me see what's going on here. So DMZ Web 01, that's this guy. He's going to be IP address 20. And this guy's 21. Oh, I know why I'm not pinging, because there's no contract yet. So let's create a contract here. If I go in, so again, this is a good test, right? So if I ping the 99.1, which is the actual Palo Alto DMZ interface, you're gonna notice that I have no connectivity. So let me go into, log out here. Hang on a second. Let me log back in. Let me go to tenant Internet Edge and go to the AMP DMZ. So what I want to do here is I want to create a contract. So we know that the ASA and Palo Alto interfaces are here. So the .1 and .2 address lives here. So I want to make sure that DMZ1, when it hits its default gateway, if it has to route outside of that subnet, it's going to connect to the firewall DMZ. So I need to create that contract. So the consumer is going to be the firewall edge, basically anything behind the firewall outside of the DMZ, and the provider is going to be the DMZ1 service. So I'm just going to create a contract here called DMZ services, and I'm going to do no filter. Just going to allow it all through, because I want to make sure that it all works, and then later down the line you guys can come in here and start adding some filter entries. Maybe you want to only allow SSH or port 80 or 443 or whatever. But in this case, just for this test use case, I'm just going to put no filter, no whitelist security, no east to west firewall protection. Hit OK here, and I'm also going to add it for DMZ2. And I'm going to connect to the same contract. Oops. Sorry, let me go back here. submit this here, and then go in here, and I'm going to choose that same contract, DMZ services. So basically that contract, all it is just permits any. I'm going to submit here, and now we have a contract with the firewall DMZ, and it's basically permitting all. So let me go to my web DMZ. And we got to do some testing here real quick. So let me make sure my interfaces are in here correctly. I'm not getting any. Oh, because I didn't associate the domains yet. Where? Hang on a second. Okay, so I did the domains for the public edge. Okay, I apologize. So what I need to do here, I need to add the physical connectivity. So we need to now add the ASA and the Palo Alto into this. So let's put the Palo Alto physical domain, and we're going to add the ASA data interface, and we got to statically bind them. So for the Palo Alto's coming in on this virtual port channel policy group, and it is they're both going to be on 2000, VLAN 2000, as you see here. So VLAN 2000, it's going to come in on a trunk, and I'm going to add the virtual port channel for the ASA here, and that's coming on the data interfaces trunk as well. So by adding this, now I should start having communication. I guess I forgot to, I missed this spot. So I'm getting, I'm learning the configured the client endpoints now. Here are the access policies that are deployed. We open up the web, and I should have connectivity now. There you go. So the reason why I wasn't pinging was because of the physical domain. Basically, the firewall wasn't really attached to it. Although it was attached, it wasn't logically attached. And here's the ASA firewall. So .1 is the Palo, and .2 is the ASA. And without that contract, we wouldn't have connectivity. All right. So we pretty much let's test, make sure that this DMZ1 host that's connected in here, the .20, can access this .1. Because if it can access this .1, that means that we have proper connectivity from the Palo Alto to the internet edge. So I'm going to ping 200.200.1, and if I get this to work, that means that we have perfect configuration. There you go. It's pinging. So we have outside access from the DMZ now. All right. So now this portion is all configured, operational. Let's configure the tenant campus, the VRF campus, bridge domain campus, and the campus edge EPG so that we could create that meet-me zone between the ASA inside campus interface and the campus router. So my fabric policy is already configured, so I'm just going to basically add a tenant called campus. We can also create a VRF called campus as a shortcut so we could get this configured quicker. So there's already this campus. We're going to create a bridge domain called campus, and it's going to be part of that campus VRF, campus. We know unicast routing, but we're going to do ARP flooding and create an application profile called AMP campus, and we're going to create an EPG called campus edge in bridge domain campus. And what we're going to do here is we're going to link the inside campus interface of the ASA and the campus WAN router or switch So we're going to go in here, we're going to add the physical domain for the campus physical domain and the ASA cluster interface. We're going to statically bind them. So if I remember correctly, the router was on 202 port 3 using VLAN 900. That one we're going to set up as an access untagged, so just an access port. And we need to add the firewall, and the firewall is on a virtual port channel using the data policy group. And we were connecting in on VLAN 2001. That's in the trunk. Okay. So this, give it a second, this is going to clear up. And it's starting to. So this is the connectivity and between the firewall and the router. Let's do some pinging. 10.100.0.66. Just make sure I ping myself in 66. There you go. So I have connectivity. I need to enable the routing process on that campus and WAN switch. Okay, but we'll skip that for now. So we have now established this connectivity here. So let's create our tenant corporate and VRF corporate and configure this bridge domains and EPGs, and then finally our layer 3 out. So let's go into add a tenant, and we're going to call it corporate, VRF name corporate. Okay, bridge domains. So we're going to create our app bridge domain. It's going to be part of corporate. It's going to have an IP subnet defined as 10.101.1/24. And make sure that we can advertise this out to our layer 3 when we create it. Let me do the same thing for web. And database. Alright, so I got my bridge domains, and the bridge domains have the subnets defined directly under them. These are my default gateways for the EPGs that are going to be associated to them. So let's create that application profile. So we're going to do ANP corporate app 1. Let's just call it. EPG is going to be app DMZ. It's going to be in the bridge domain app, and we're going to associate our VMM integration here. So we're going to push a port group for this EPG to the actual ESX hosts. We're going to do the same thing for web. And we're going to do the same thing for database. Okay. So if I look here, I should have my integration for app DMZ, DB, and web. If I go to my ESX host here, I'll see that, so for example, prod app, if I change the network adapter here, I'm going to notice that I have my port group now because I just pushed it out. So I'm going to associate this to the app DMZ EPG that I configured. I'm going to associate web to the web EPG and the database to the database EPG. Awesome. Okay, so that's that. Now let's configure our layer 3 out. So what that layer 3 out is going to be is this right here. This is going to be our layer 3 routed connection outside of the ACI fabric, and it's going to basically be an adjacency that I want to form with the ASA on VLAN 2002. So the IP addresses that I'm going to use are 10.100, 2, and 3. And I got to create these loopbacks for each of my leaf switches because we're going to be doing routing over VPC. So let me do that real quick. Create routed outside. ASA L3 out. We're going to do OSPF, random and area 0, regular area, VRF corporate, routed. Oh, we forgot to do a routed domain. So let's create that routed domain on the fly. This is basically a routed connection for the ASA. So ASA 5500X cluster data L3 domain. The AEP is the cluster data AAP. VLAN pool, we gotta create, no, we don't have to create a pool. We're gonna use the same pool that we have for the cluster. So we're gonna use this cluster pool, submit, and we gotta configure our nodes and interface profile. So I'm gonna go in here, so to say OSPF node profile, and we're gonna say leaf 201 is 10.100.0.254. And leaf 2 is 10.100.0253. Now I got to configure my interface profile. So OSPF and profile. Now here I can configure authentication. I can do BFD for faster convergence. I can do a lot of things, but I'm just going to keep it simple for this this demo. I'm going to use an SVI because I'm peering with the firewall, and the firewall is already configured for VLANs. So I am going to use VLAN 2002. So it's going to be a virtual port channel connecting to the Cisco ASA cluster policy group, which is a virtual port channel. I'm going to define VLAN 2002 and the IP addresses. So we're going to be using 10.100.0.2/26. Yep. 0.2 and 3/26. 10.100.0.3/26. This is basically for leaf 1 or leaf 201 and then leaf 203. And then the MTU, we want to hard set that to hard code it to 1500. Hit OK here. Hit OK on the profile. And hit next here. Now I got to configure my or classify my external EPG. So I know that I want to be able to create a separate policy for my my DMZ segment. So I'm going to classify my 1099 as a particular EPG, and then a quad route, which is going to classify everything else as a separate EPG. So I'm going to go in here, DMZ servers, and I'm going to say 10.99.99.0/24. And I'm going to create another EPG. I'm just going to say external EPG all. Use the quad route here. So here are my two EPGs. One EPG is DMZ servers, which is the 10.99.99 subnet, and EPG all, basically anything else that's coming in is going to be classified part of this EPG. Hit finish. And let me check I can go here, configure nodes. Okay, so I'm already routing. You're seeing here, I'm seeing that default route coming from 0.1, which is the firewall. So we have already an active adjacency and we're configured. So let's go to the firewall real quick and just double check that. Show route. So we're seeing the loopbacks. And show OSPF neighbor. So it's still forming. So while that's doing that, let's go in and associate our bridge domains to the layer 3 out so that we can actually advertise it out. So under the app, I'm going to go to layer 3 configurations, and I'm going to set my ASA layer 3 out here so that I can advertise this network where it says advertise externally. I can advertise this network out and the database as well. Let me go in here. And the web. All right, so here are my routes. The 10, 1, 2, and 3. And I'm also doing a static route here, and that's being injected into the routing table, into the ACI fabric actually. So if I want to ping, there you go. That's the actual bridge domain. Let me see about a host here. Prod app. Establish these connections. So if I go to prod app, ping 10.100.1.1, which is its default gateway. I have connectivity. Let me ping 10.99.99.10. I don't think we'll have, no, actually 20. Well, actually, let me ping the Palo Alto. Yeah, I'm not going to be able to ping it yet. I need to create a contract. So if we go back to ACI here, and I go to my application profile, I need to create some contracts. So let me get my layer 3 going here. So this is the external EPG all. So I'm going to create. Let's see, what can I do? Let me do an external all first, and I'm going to create a contract between web and external all. So external all is going to be the consumer, and it's going to connect into my web. And I'm just going to say out to, well, let's just call it web services. And I'm going to put no filter. So actually, no, let's put a filter. Let's do ICMP. Let's also do SSH. No, this happens sometimes. I'm going to have to rebuild it. Oops. Actually, let me modify that a little bit. Let me do HTTP. And ICMP. Let's do SSH. Okay. So I have a contract from my web server providing web access, which basically consists of ICMP, SSH, and HTTP. So anything from the outside can connect into the web server on ports 80, SSH, or ICMP. So let's test that. We can probably test that, but I gotta configure natting on the ASA firewalls for those IP addresses first before we can start testing with the DMZ. But let me test on not product. Let me open up the web. So here's prod web. Just make sure I have default gateway connectivity. I do. And I should be able to ping now the 10.99.99.1, which is the Palo Alto. Oh wait, no, because that's part of the other network. Let me ping. Let me see if I could ping 200, 200, 200. Actually, I won't be able to ping 200, 200. Yeah, I'm gonna have to do some natting on the ASA first. So let me do that first. All right, so what we need to do is configure, there's a host here. Actually, the host that's going to be coming out of here is 10.100.1.10, and we want to NAT it to 10.99.99.10 so that the DMZ can respond directly to it. All right, let's see. Object. Network. Inside. Actually, we'll call it app 01 to DMZ servers. Host 10.100.1.10. And that it's coming in from the inside data center. It's going to the outside DMZ. Static. Static. We're going to give it 10.99.99.10. So it's going to pretend to be the 99.10 address. And we already have an access list that permits everything, so we should be in good shape for that. So, oops. So we got no hits on that. Okay. So what we want to do now is our app. So our app has a translation, but we're not going to be able to let's just try to ping the outside. We're not going to be able to ping the outside. Let's ping. We're actually not going to be able to ping anything because there's no contract, right? So this is the app DMZ EPG. We got to establish a contract. So let's get our layer 3 going, and let's do the DMZ servers. Okay, so this is the DMZ servers. Let's get a contract between app DMZ and DMZ servers. So this is basically allowing connectivity from the 10.100.1.10 to the 10.99.99 subnet. So the DMZ servers are going to be a consumer, and they're going to consume the EPG app DMZ. So I'm going to say app DMZ services, and let's get creative here. Let's do a real contract. Let's do SSH. And let's do HTTP. port 80. And we're going to test this. Okay, so we know that SSH and HTTP work. You know what, let's just put ICMP just in case. Alright. So my contract here is basically the app EPG is providing, okay, it's providing, come on, it's not showing up, but basically it is providing HTTP, ICMP, and SSH. So I would be able to log on to the DMZ server. So here's my DMZ server. The DMZ server has outside connectivity. There's a contract that it has with the EPG that the firewalls are in. So basically anything outside, it's a permit all east to west contract. So it has everything has connectivity. So there should be nothing stopping it from connecting to the 10.99.99.10, which is the translated address. And there it goes. So ICMP works. Let's try SSH. SSH 10.99.99.10, because this is my NAT translation. And SSH works. There we go. And let's do telnet. Oops, port 80. Actually, what is the command? Is it 10.99.99.10 on port 80? I think that's what it is. Yep, and it's open. So my contract is allowing that in. Now let me go back in here and let me change this contract around. So we go to security policies, contract, app DMZ services, and let me go in here and let me remove HTTP. So now I only have ICMP and SSH. Let's see what happens now. So I should not be able to telnet to port 80. And look, I'm not able to telnet it to port 80 because the contract, the east to west protection now is blocking it. Okay, so I'm back. So let me just add it. HTTP. This is the beauty of the stateful or stateless whitelist firewall. Okay. So what do? We just established communication. Let me grab this here real quick. Grab it like this, so I can scrabble on it. So we just established communication from the DMZ firewall. And before I go into that, let me double check something. So let me go to the DMZ firewall here. We're doing a myTR for 10.99.99.10. And look at that. The only hop it goes to is the actual ASA firewall. Otherwise, it will go to the Palo Alto, but it doesn't. It goes to the ASA firewall. So what that means is that when the DMZ server, for example, this DMZ server here, or this one here, the .20 or the .21, when it has to consume the EPG DMZ app resource, what happens is it makes there's a contract here, right? We set up that contract here. So the traffic flow is basically going over this contract, which allows me to have communication with a gateway, which is the Palo Alto or the ASA, and it knows it has to go to the 10.99.99.10, which is going to take this route to the ASA firewall. The firewall is going to receive that request, is going to NAT it back to its real address, and it's going to forward it over this OSPF link in through that ASA layer 3 out into that EPG app DMZ and out to that host. And we just established communication from internal to DMZ and from the DMZ to internal. What we also established is in the previous testing scenario here. For example, if I was to log on to the DMZ server, if I'm able to ping 200.200.200.1, I'm actually testing connectivity from outside to inside. Now, if I really wanted to see what the connectivity is from, actually from inside to outside, inside DMZ to the outside, Now, if I wanted to test connectivity from the outside, let's call the Internet Edge router, to this particular DMZ web server, I can. Let me log into that switch router real quick. So here's the IP address that I have, and I can do a ping VRF. Oops. So I want to ping 10.99, or actually 200.200.200.20, which is that host natted. I'm going to source this from 200.200.200.1. And there you go. That's connectivity verification validation that we have connectivity from the outside, and I just pinged it from this router. We have connectivity from the outside, traverses the public edge EPG, comes into the Palo Alto external interface, and back out of the trust DMZ interface. So what we have accomplished here is pretty much a multi-vendor security strategy where we have the Palo Alto acting as our external firewall and the ASA firewall acting as our internal firewall. We have a multi-vendor security strategy. Let the Palo Alto filter out the internet noise, let it provide the DMZ protection, and any other traffic that has to traverse into the internal data center is going to pass through the ASA and let the ASA work its magic there. So basically, this concludes our video series on multi-vendor security strategies. I thank you for hanging in with me for this long session. I really hope that this was useful, and I'm going to be creating some more advanced videos in the near future, maybe some managed firewall deployments, let ACI manage them, or some, with service graphs, or some unmanaged deployments, layer 3 routed or transparent firewalls. I'm also going to include F5 load balancers so you guys can see the full picture here. Okay, so I want to thank you all for joining me here, part of this video series. And if you guys want to have, if you're looking for any professional services with ACI, please contact me at ralph.carter@cdillc.com. Thanks.